After watching the video on the nuclear bombs, I am now able to identify what's really occurring in the reactions that take place to explode either a hydrogen or atomic bomb, as well as what components are necessary to achieve the chain reaction required for nuclear fusion. So, first, I want to give a little bit of background on nuclear bombs, as stated in the video for this assignment. Um, First off, weapons of mass destruction that use nuclear energy to create an explosion are considered nuclear bombs. And this energy that I'm referring to, in turn, is contained in atomic nuclei and is released during nuclear reactions, and as well as radioactive decay. The types of nuclear bombs are atomic bombs and hydrogen bombs, most commonly. So, what is really occurring inside of this reaction? Simply put, it is a chain reaction of the fission of heavy nuclei. Several elements are capable of this reaction. I would say, or the video says that the most common element is uranium. For hydrogen bombs specifically, the energy is released is due to thermonuclear fusion, and a really quick, fast reaction takes place inside the charge, and that's what's happening in hydrogen bombs. So now I'll go more into what components are necessary to achieve this chain reaction that's required for nuclear fusion. So first I'll explain a little bit more about the structure of an atomic bomb. So as I mentioned before, uranium is a common element used for atomic bombs, and more specifically, the most effective is uranium-235, which is an isotope of uranium. And as we learned this week, isotopes are different forms of an element where the number of protons is the same, which is why it's the same element. The number of neutrons differs. Now, to obtain the maximum amount of energy during the explosion of an atomic bomb, the content of the 235 isotope of uranium could be up to at least 80%. An interesting thing to note is that if something goes wrong, a plutonium bomb could be made a mistake. And this is pretty interesting because this element is rarely found in nature, or rarely naturally occurs. So, to launch an atomic bomb, an explosion will occur because a certain mass of fissile material is concentrated in one place, and this is known as the critical mass. So, when the critical mass is reached, a nuclear decay reaction forms with the decay of energy. It's important to note, though, that just one critical mass is not enough. You would need 4 to 5 masses or critical masses of matter to launch an atomic bomb. So how do we achieve this? One approach is the implosive technology, which creates a guided explosion from the outside of the bomb. So essentially what happens is that when the inside of the bomb is exposed to this explosion on the outside, the space on the inside of the bomb shrinks towards the center of the shock wave. And when this happens, the density of, for example, uranium-235 will increase, and that's when a nuclear explosion will result. This is relevant in the real world because in 1945, the United States dropped 2 atomic bombs in Hiroshima and Nagasaki, Japan, 3 days apart, killing between 129,000 and 226,000 people, most of whom were civilians. And this is mentioned in the video that we watched this week. And these events remain the only use of nuclear weapons in armed conflict in the history of the world. Now I'll explain why hydrogen bombs, what is necessary to achieve a chain reaction, And what's necessary is lithium hydride. That's the main effective substance in hydrogen bombs. It is integrated into a nuclear device or detonator, and energy is released when that is activated. Another important thing to note from this video is radiation that occurs when a nuclear bomb is dropped or matter is released. It's caused by an explosion, and there can be alpha, beta, or gamma rays that contaminate the area surrounding the explosion. Alpha rays don't really do much harm, even clothing protects you from it. Beta can do a little bit more damage if you're meters or even feet from the source, such as radiation burns or cataracts in your eyes. But gamma is the worst, that permeates your body and causes damage, such as radiation sickness, cancer, or even genetic mutations.